Welcome back to Joe's Computer Museum. Today we're going to do a quick wire wrap tutorial. So what the heck is wire wrap anyway? Well, it's an old school way of connecting wires to terminal pins in order to connect components together on a circuit board. Devised many moons ago. But the thing about it is it works, it's super solid, and it is very resistant to corrosion, oxidation, vibration, or anything like that. It's probably the best way for doing prototype circuits because it allows you to do your circuits fairly quickly, but it doesn't involve those nasty solderless breadboards that can have lots of inductance and reflection and noise and bad connections and all of that stuff. In addition, it is reversible because we're not using solder. We can just unwrap the wires and redo a circuit if we need to. So let's talk a little bit about how that's done, what tools you need, the materials you would need, and then we'll actually wrap a board up here and show you what it looks like. So let's talk about the tools first. The first tool you're going to need is a wire wrapping tool. This is a standard wire wrapping tool. This is usually one that most seasoned wire wrappers would prefer. It's got the nice hex grip. It's aluminum, so it's lightweight. It's got the wrapping end, and it also has the unwrapping end. This one even has a stripping tool in it. Sorry, I'm going to turn that light off. It's flickering in the background. I don't like that. So this is almost an all-in-one tool. Next tool you'll need some clips. These are the standard 170M style flush clips, wire cutters used for close-in electrical work. Allows you to get close into boards and stuff. But I mean, when you're doing this, you don't necessarily need clippers like this. You could use a standard set of diagonal cutters or snips or something. You could use, something like these big things. Basically, you just need something to cut the wire with. I find it nifty to have these because they're quick, they're lightweight, they're easy, they work well, and they're fairly universal for working on smaller work like this. So if you're doing a combination of both wire wrap and soldering for whatever reason, this will help serve multiple purposes. Other tools that are very helpful, a ESD compliant pair of tweezers with super duper fine points on them. Can we see that in the camera? It doesn't want to focus. That's fine. But yeah, these allow you when you're working in your circuit to get really in close and direct wires exactly where you need it to go, pull it in different directions and stuff. If you're working to unwrap your wires, it helps to get in there and pull them out. Extra helpful is the black nylon stick. Non-conductive, it's pointy, it's got a pointed end that can help you hold on to wires with the tweezers one way and pull on it another direction to get things routed and make them look neat if you want to. It's good for pushing wires down and pressing things into crevices. They're generally helpful to have around when you're working on electronics generally, because you can just use them to scrape stuff off boards and whatever. Because it's not metal, it's not harsh. It's got a soft, relatively soft nylon end on it. So useful for that. Now we need to talk about the different materials you're going to use when doing this. Of course, you're going to need a board of some kind. This is an FR4 board. That means it's a fiber resin, FR. It's like a glass fiber. It's technically just fiberglass if you want to, use the brand term, the brand name on it. But FR4, they're nice and stiff. That allows you to press down on it and work with it without it deflecting or bending. You can use boards like these phenol boards, but these have a lot of flex in them. They're a lot cheaper, but it comes from the factory curved, and I don't know. Just your mileage may vary. It depends on what you're using it for. These tend to be a little bit more expensive. This is also a dual-sided board, which I found can be helpful if you're putting your pins in there and you're trying to tack things down with a little bit of solder to keep them from moving, or you need to put components on both sides of the board for whatever. Having the dual-sided board is helpful. The best boards for doing wire wrap are boards with a ground plane. I'm going to zoom up here way in on this if the camera will let me. So you can see this has just plated through holes effectively. The best boards, between each of these through holes, down in between here, it's going to have a solid ground plane in between all of those that will then connect to a ground point at either end of the board, or sometimes both ends of the board. That's best because then you can actually achieve a full ground plane on your board. Ground planes are very important. It has to do with decoupling and signal noise in your power lines, especially with high-speed digital circuits. I've talked about decoupling capacitors before and how your chips should have decoupling capacitors on them to provide that little extra oomph of voltage, when switching occurs, because there's natural inductance and capacitance in your power rails. Having that extra oomph helps there. Getting super technical, but when you have a full actual ground plane that your capacitor is connected to, you have the least inductance draw possible on your decoupling circuit, and it greatly improves performance and greatly decreases the noise. But, if you can't get those, that's fine. A little Ina Garten moment. If you can't get free-range, high-quality boards directly from Israel, go ahead and get them from China. They'll be fine, one of those types of things. But seriously, though, just about anything will work well for you. Next thing you're going to need are wire wrap pins. These guys right here are square pins. I'll see if we can get up super duper close. Can we do that? Yep, so you got square pins here. You can see they have square edges as I turn it slowly. And that's what you need for wire wrap. You can get them with multiple levels. This is a 3-level pin, but you can get them with 2 levels, which is about 2/3 the length of that. What's important about these pins is because they have the square edges, when you twist your wire on there, the edges of the wire will actually bite into those square edges and give you like an oxygen type, an airtight, moisture tight seal between the wires, and actually will create a small chemical weld. It's very interesting how that works. We see that in the IT industry too when we're doing punch downs on network termination on 110 blocks or 66 blocks when you punch the wire, and it's the exact same concept. It's a metal on metal compression fit that actually causes a chemical weld between them and makes it effectively like solder but not permanent. It's pretty cool. I like to use these bulk pins here, and I can pull out a whole section of them. These are what I like to use. The bulk pins, they come in like chunks of 10, 20, 30. These are 30 chunks. I get these from Jameco, basically because they are the cheapest way to get wire wrap pins that I have been able to find. You can get wire wrap pins, or you can get like sockets if you like, but I found that they're really expensive. You're going to get a sockets even with like decoupling capacitors already attached and just all types of stuff. But these I found are just the least expensive way to get your sockets that you can do. Of course, they come with machine pin holes, the nice round holes, so they'll fit just about any component you want to shove into them. Other components, yes, we'll need wire. So, this is just standard 30 gauge Kynar wire wrapping wire there. You can get these. This is a little 50-foot spool. I've got this thing that's either 100. It's either like 1,000 feet or 1,000 meters. I don't know. It's a lot. It's a friggin' lot of wire. That's all I know. And this was like $8 or $9. It was super cheap. And the quality of this wire, if you see this VT Corporation stuff, it's really good. I like it. It works well. But this is like OK Industries wire wrapping wire. This is even higher quality. This stuff is like super duper good. But whatever. As long as it's not like the absolute cheapest piece of crud on planet Earth, you'll be fine. With all of that, then you need a component. You're going to need something to put in here. So we're going to go ahead and we'll demo this with the venerable 555 timer, and show you how that fits into the wire wrap socket. So let's actually start by doing a wire wrap. Of course, you're going to want to, when you're doing wire wrap boards, it makes sense to try to design, at least get a basic idea of how you want to lay your board out ahead of time. Because with wire wrap, you can like remove stuff and put it back on, but it is a little bit of a pain in the butt if you get the board half wired and realize you don't have enough room for this other thing or whatever. So when you're putting your board together, put a lot of thought into how you want it laid out. And then you'll also want to make sure that you put your sockets as close to each other as you possibly can. 2 reasons. 1, you save board space. 2, the advantage of wire wrap is you're making your wire connections between your different components as short as you possibly can. This is very important for high-speed digital circuits. It reduces inductance, ringing, and all those other nasty effects by having this connection super short. I'm going to move these to the middle of the board because it's going to be a little bit easier for demonstration and doing the thing. Now, you just put your sockets in there, you figure it out, and you start wrapping pins. This is pretty straightforward stuff. Now, I've been cheating here a little bit. I've been breaking my own rule. But couple of important things when you're doing wire wrap. One is you're not supposed to touch the pins with your fingers like I'm doing like this. This is a demonstration, it really doesn't matter, I guess, but the reason being the oils and whatever might be on your hands, I don't care how clean your hands are, they got nasty stuff on them. Those can contaminate these pins and can foul that chemical joint, that chemical solder weld joint between the wire and the pin. So you have to be careful with that. And the same thing with the wire. When you work with and strip the wire, don't touch the metal. Leave that alone. So go ahead and put our pins in here. We have that set the way we want it. So now let me refocus, make sure we're down on the board. So now we got to figure out what we want to do. So let's just make something up. Say I want to connect, this pin here to this pin over here. So let's figure that out. When you're doing your wire wrap, you want, they say approximately an inch, basically like 3/4 of an inch, probably, maybe, about something like that is how much you want. So when I do this, I'll do that, I will fold it over, I will find the pin I'm starting at, and use my tweezers, and hold it around that pin, then come to the pin I want to end to, put a little bend in it, and then crimp it so that I've got 2 nice hard corners like that. This will be my run distance, and this will be my wrap distance. And so then we cut that wire off, and that's the wire we want to wrap. Now we need to strip the wire. So what we can do is we put it in the strip tool. I give them, even though I put the bend right here, I come back from it a little bit. And the reason is you want a little bit of insulation here so that you can perform overwrap effectively, so you can wrap the insulation around the bottom of the pin first, then come up with it on the wire. Reason being, if you're wrapping more than one wire on there, it makes it less likely that you're going to overwrap wire with wire itself. If you put one wire completely over top of another wire, what are you not doing? You're not biting that second wire into the edges of those pins, and therefore you're not getting a good connection. So that having that little bit of insulation as, I guess, as a lead-in or a leader, helps with that process. So we put it into the strip tool here, leave it a little bit of excess, bend this down, and you want to hold on to the insulation with your finger, because you need to pull this down into this tiny, tiny little slot. I don't know if you can see it. There's a tiny little strip slot there that we need to pull this down into. Pull it, and there's our wire. Now that the wire is stripped, what do? We do not touch the wire itself. Got it. So let's do the other one here. Now granted, that can be hard not to touch that wire again, but we do our best. Put it in, leave a little bit of insulation, pull it down and pull it out. And there we have our wire. So now we have to insert it into the tool. So I'm going to try to get up super close here, if the machine will let me do it. Here, focus on my hand. There we go. So what you can see in here, if I can tip it up to the end, it's hard to see. There we go. You can see there's the main shaft down the middle of it, and then there's a tiny little hole on the one side. And then that comes out right in here, and you have this little slot that the wire can run up. You want to get your wire from this end in that little hole, up through there and out, and keep pushing it until you can see the tiny bit of insulation there in the end of that. Basically, you want to push it till it stops. Then you put that down, put it on your pin. Sometimes it can be difficult to go on the pin. Then you turn it. Now, the trick here when you're turning this is to not put, oh, are we focused? Better. Is to not put too much downward force on it. I found you do need to put a tiny bit of downward force on it, but not a lot. The reason being is if you put too much downward force on it, you end up overwrapping the wire over itself. If you don't put enough up, or if you put any upward force on it at all, instead of having the coils of the wire, wrap right next to each other super tight, they end up wrapping around like this. And then you're just wasting space. It's still a pretty good wrap, but you're wasting a lot of space on that pin that you could use to put other things on there. So let's go ahead and take a look at this wrap. This wrap did not feel good to me when I was wrapping it. Does that look good to you? Yeah, that doesn't look too good. Let me take a real quick look. Yeah, something happened with that. I don't know. And that happens sometimes, and you'll know. It'll feel tight. It won't feel like it's going on correctly. That's fine. You just use the small end of the tool. Man, I'm just bad with the focus today. You put the small end of the tool on the wire wrap pin, turn it a few times, and we'll loosen it, and it should come right off. Except in this case, because this wrap's so weird, it did not come right off. That's weird. Okay, well, that's no problem. We will do it again. So I need about that much. Eyeball that. We don't have to be super perfect here for demo purposes. You also don't want, when you're wire wrapping, you don't want your wires like insanely tight or whatever. You want to have a little bit of play in them so you can get other wires around through, underneath, over top of it. And just gives you room to play with. If you try to do it too tight too, you can find out, okay, that just ended up pulling that off that end. Wow, I'll tell you what. For a demo tutorial for you guys, this is being very, very persnickety with me. Every time I do this, it just doesn't want to work. Pulled the insulation off that wire. Grumpy Joe. Okay, let's try it one more time. There's that. I'm going to need it about there. Again, I'm just eyeballing it. Just eyeballing it for demo purposes. It keeps pulling the insulation off the wire. Let's try our cheapo Chinese wire, shall we? Let's see if the cheapo Chinese wire does a better job. Okay. Dooby-dooby-doo. This is where you can speculate in the comments how drunk I am at the moment. The answer is, I'm not drunk at all. But it might look like it with all the screw-ups I'm doing with this wire. So let's do that. Yeah, that stripped much easier. Let's try this again. Get our wire up in here. Insulation all the way down to the end. Put it down on there. Twist it. Slight downward pressure. I'm just holding that in the crux of my first finger, my index finger there. Not a lot of pressure, just a tiny bit. That felt much better. Oh, that's beautiful. Let's zoom in and look at that. Beautiful. wire wrap. Oh, that is just delicious. That is how it's supposed to work, folks. Yep. So, we got one on, so we need to wrap this one over to this other pin. So we pull it this direction. Now, when you're wrapping wires, you got to think about the direction that you're going to be turning. I always like to turn my wires when I'm putting them on, this just like you were tightening a screw, you know, clockwise to tighten, counterclockwise to untighten. So I do it the same way. You can wrap them either direction if you want to. That's fine. But when you're doing that and you put this on this other pin, you have to think about the side you want that wire to go around. I could put it here and then wrap it, but when I try to wrap that, it's going to basically be wrapping in the direction that it's coming from, so you're going to end up with a loose connection. But if you put it on this side, you're going to be basically wrapping it around the wire in the same direction like that, which is going to pull it tight a lot better. Now in this case, it's not really going to show effectively because, you know, this wire is too long, but that's fine. Get that in there, all the way in there, down, and turn. And the wire is wrapped. Now I do have a little bit of an extra loop on here. You can kind of see it here because the wire was too long. But the cool thing is, because of the way I have this wrapped, it's easy just to use your tweezers and pull that tight, just like that. And now it looks super duper pretty. And if we look at that, the wrap on that pin, that is really nice. And that's really all there is to doing the wire wrap. Now, there is an important thing to note when you're doing wire wrapping. These wire wraps, or specifically, you know, the sockets, they're designed for, you know, socketable components like the 555. Now, I'm not going to push this all the way in because I don't have all the pins wrapped. It'll be a pain to get it back out. But yeah, they're really designed for chips like this. They're not designed for single components. If I try to put this component in here, it's not really going to fit into that socket hole too well. It did okay on this one, but as you can see, the leg of that is all bent over because I've tried that in sockets before, and this one bent over. Things with smaller leads like this this capacitor go in there like super duper easy. It just goes boonk and it sticks in there and it's fine. You also, when you're wire wrapping, you don't want to, I mean you can, but you want to try to avoid wire wrapping individual components. So, you know, if I put this through the board, especially this capacitor with its super flimsy leads, and I try to wire wrap onto that, those leads are barely thicker than the wire I'm trying to wrap on them. So, you know, they're going to bend and they're going to flop around the wind. They might bend together and connect together, you know, like that, and cross and whatever, and that's not what we're trying to achieve. So, you know, in this case, you want to try to have some better permanent solution for this. Now, I don't have the thing that you're supposed to use for these, but they make little sockets or little pairs of headers that instead of having these round pins, they have a set of scissor connections or pinch connections, almost the same way like a 110 block does on a you know, a termination block for phone or Ethernet. And you can use that to actually, you know, press your component across those bite connections and stick it in there that way. That's really the way you're supposed to do it with components like these. Other things though, like, you know, let's grab something like this, like a color change LED. LEDs have typically square posts. They have fairly thick square posts. So in this case, you know, this would be a good example of something you could just wrap right to because it's square and it's going to bite in. That's another reason there why you don't want to try to wrap to components like this, is because those components, they have round leads. So basically you're just wrapping a wire around another wire and it's not biting into the edges and making that gas tight connection. If you're doing components on the board and you do wire wrap to those components, just keep in mind that once you're done with your prototype, for these individual components, if you don't need to be doing anything like moving those components around, you'll want to take your soldering iron here and actually solder. Go ahead and solder those wire wrapped wires onto the component there, so that it makes that solid connection. You won't have any issues with it in the future. Well, that was all I had on wire wrapping, just kind of the ideas and thoughts and things that I found when I was learning how to do wire wrapping on my own. I hope you found that informative. If you have any questions or thoughts or angry ruminations, leave them in the comments below. Check me out on Facebook or Instagram. And remember that 8 bits are all you need.